here we have a Green's theorem question, except that if you look at how the boundary is oriented, it's oriented clockwise, right? So you can't use the regular Green's theorem because if you go around clockwise and you do the line integral, that's same as negative of going counterclockwise of the line integral. And therefore, although this much is same as the double integral of some curl of dA, because of this minus sign, you're going to need this minus sign. And if you say P, the vector field F has x component as P and y component as Q, in our case this will be our P and then this will be our Q, then this is what goes inside. Okay, so apart from that, this is the standard Green's theorem question. Let's look at the domain and see what happens here. It says x naught and y naught is 4, so it's 4 comma 4, and this is 4 times 2, which is 8 comma 4. This is 4 comma 0, and this is the origin 0 comma 0. And if you see that this length is 4 and this length is also 4, and these are both parallel to each other because it's a horizontal line, then you know from high school geometry that if you have a quadrilateral where two sides are parallel and they have the same length, then this is a parallelogram. So hopefully you know that theorem, or you can also show that this side is parallel too, just by doing terminal minus initial. This vector is 4 comma 4. If you do 8 comma 4 minus 4 comma 0, that's again 4 comma 4. So these are same identical vectors, so they are parallel. So we have these two parallel, so we have a parallelogram. In any ways, you have a parallelogram, and note that because these 2 points have 4 as its x-coordinates, they're directly above each other, and that kind of helps because that means you can cut and paste this over here, and the area of this is 4 by 4, so we know that the area of this quadrilateral or this parallelogram has area 16 because it's height 4, base 4 square if you cut this part and paste it over here. Okay, so that's going to be used a little later. Now let's continue with this calculation. Since p is x cubed and q is 3x, and you have to differentiate partial like this, dx hits 3x and dy hits x cubed, and you have to do AD minus BC. That's how you do determinant of a 2 by 2 matrix, right? And when derivative with respect to x hits 3x, 3x differentiates to 3, so it's just 3. On the other hand, when you differentiate x cubed by y, this is a partial derivative, so if you differentiate by y, that means you're treating x cubed as a constant, so you get 0 if you differentiate by y. Okay, and that means we have negative 3 times the integral of r 1 dA if you factor the 3 out, and this is the area, right? Therefore you have negative 3 times 16, which is the area, so you get negative 48 as the answer to this question.